Next, as part of the NLP pipeline, we'll take a look at, in the case of text pre-processing, what is stemming and why we need to do stemming and what are the advantages. We will take a look at it. Stemming is performed in NLP, right, for variety of reasons. Primarily to reduce the words to their base root form. Okay, for that purpose, we use stemming. Okay, it's kind of a normalization process. It offers benefits in terms of text analysis and information retrieval and computational efficiency. For that purpose, normalization process is very much important. Now let us explore some solid examples with data to understand why stemming is required. So basically, you want to reduce the words to their base or root form. For example, you have something called cooking. This is a original word, right, in your text. So in that case, when you do the stemming, instead of cooking, you can get cook. Okay, you can get cook. Something like cooking recipes are useful for beginners. In this case, cook recipe or useful for beginners. In this case, basically what it does is it removes the prefixes and suffixes, affixes, everything. Prefix, suffix, affix. It removes them, the stemming, and it gives us the root word or the base word for any word. So it may not always produce accurate results for all words, because as part of stemming, we are just removing it just, this package just removes the prefix and suffix. That's all. Okay. There are cases it will not produce the accurate result. And also it can lead to overstemming and understanding some situations. Okay. And why stemming? Why do we need to do stemming? It can help improve the efficiency and accuracy of text analysis tasks. This is useful in tasks like text classification, sentiment analysis, information retrieval. What is information retrieval? Can someone tell me? What do you mean by information retrieval? Search engine, right? In the case of search engine, the stemming makes sure that the users like us can find the topics or documents, even if we use different word forms in our keywords, right? Still, it is trying. So, for example, information retrieval, I want to search it in the Google. In that case, even if I do some typo, for example, I the probably some spelling mistake, right? Still, it is able to still the search engines are able to search the relevant documents which we are looking for it in the internet, or the relevant URLs. This is all possible because of stemming. Okay, because um, it reduces the words to their base or root form. Okay, and the dimension of the data reduced. Obviously, the dimension of the data get reduced, and spelling variation, information compressions. Okay, in case of any spelling mistake or any information compressions, instead of typing information retrieval, if I type info retrieval, right, still it goes and finds out the topics that are relevant to information retrieval as well. Okay, so for these reasons, stemming is very much helpful, though it is not accurate. It is helpful in terms of text classification and all. Okay, text analysis or text classification. So in those kind of situations, this is very much helpful. And it reduces the dimension of the feature space when you build the models. Okay. In turn, right, by reducing the dimensionality, it can improve the model efficiency and prevent overfitting in some cases. For example, you have something like what do you say? The example is I run daily. She runs every day. I run daily. She run every day. Okay, the Y will get removed. Every will be there. Okay, see I just write it here. Sorry. Okay. Yes. Sorry, I will write it. Don't worry. See, you have something called I run. I run daily. I run daily. She runs every day. In this case, this is your original text. Once you do the stemming, it will remain as it is. Okay, I run, DAIL. In this case, it will put I here. Okay, instead of Y, it put I. And she ran every I. Instead of Y, it put I. Okay, every day. Again, depends on your stemmer. Okay, you have something called porter stemmer, snowball stemmer, different types of stemming packages are there. It varies from one package to another package. Which one? The stemming. Okay. So in this case, this is your original text, and this is how it reduces it here. Okay, the dimensionality. Okay. This is called information compression. This is called your information compression. And in this case, it reduces the dimension of the feature space. So what, okay, here, look here, I run daily, DAILI. In this case, we don't see much thing, right? Every day. We don't see much here, but still it is good. Okay. And basically it converts your, basically it reduces the words to its base or root form. So what do you mean by base or root form? For example, running. You have something called running. Okay, it reduces to its, the base form or the root form as a run. Running will become run. Okay. And runners. For example, you have something called runners. Another example, runners. And in this case, it will put RUNNER. It will remove the suffix. Okay, in this case, the ing it will remove, and run, runner, something like that. Okay. And for example, another example is cooking. Cooking, it will reduce it to the base form as cook. Cooking, cook, something like that. Okay. And okay, and you have something like beginners. Beginners, it will become beginner. Okay, the yes, it will remove it. Okay. So by removing the prefix and suffixes, obviously, right, you might find the some kind of dimensional reduction is happening here. So next one is, now we understood what is stemming. Stemming is nothing but reducing the word to its base form. And why do we need to do stemming? That we have seen it now. And this is useful in tasks like text classification and sentiment analysis. In this case of text classification, all we need to do is whether the given, for example, as I discussed yesterday, whether the given topic text is related to spam or non-spam in the case of email, right? So this is, stemming is more than sufficient. It need not to be so accurate, right? It need not to be while reducing the word to its base form or root form, it need not to be very accurate, right? So in that kind of text classification kind of situation, you can go ahead with the stemming, but stemming is a bit faster compared to other technique. The next one is, how do I do the stemming? How can I do the stemming? So we have different types of stemmer, or the stemmers are available. Using NLTK also, you can do the stemming, and you have snowball stemmer is available, using which also you can do the stemming. Yeah, what we will do is we'll jump into the this one, and here the Jupyter notebook, and we'll see how do we do the stemming. No, we will do the different case study. I have different case study. First, understand the task that you are going to do as part of text browsing. Okay, so these are just for illustrative purpose. I'm doing it. First, you need to understand the basic stuff, right? That is the reason why I'm doing it. What is that? Yeah, that we will see it later. Okay, don't worry. For example, I have something like, just give me a second here. 1 second, I'm getting a call. Sorry. Now I jump into the notepad, Jupyter notebook. And here I just import the NLTK package, NLTK, and from NLTK underscore stem, import porter stemmer. Sorry, the capital one. And next one is I'm going to use Spacey. Spacey was causing some problem yesterday, right? Import Spacey. And Spacey is not working. 1 second, let me see. System is hanging here. It's not NLTK underscore NLTK dot sem. Import porter stemmer. We have something called porter stemmer and snowball stemmer. The space is kind of working, right? Yeah, no issues. Let us see now. What we will do is we will use the words something like tell me some words, now running. You can tell me any words. Yeah, we will take running. Okay. Yeah, runner and ran. We will take run, ran, runner, and yes, you are correct. Can I use easily? Okay. What else? Better. Any other words? Okay, this is enough. Let's play around with this one, okay? But this space is still being imported. I think something wrong with it. It will not take this much of time. What I will do is NLTK stemmer equal to the porter stemmer. So this is the class that is available as part of this module. I have created an instance using the porter stemmer class, okay? Next one is, yeah, let me do, okay, better I will interrupt the kernel. Okay, we will play around with NLTK. I think okay, let me interrupt this one. It takes a lot of time. We'll start play around with NLTK as usual. So I'm going to create an instance of the class porter stemmer. And here, the next one is NLTK stemmed words, right? NLTK stemmed words. And here the NLTK stemmer is holding the instance of that one, right? So now what I do is NLTK underscore stemmer. And here what I'm going to do is I'm going to use a method called stem. Stem, here I'm going to use word, okay? Word for word in words. So this is called list comprehension. You know what is list comprehension? How many of you are aware of list comprehension? Yesterday you have asked this question, Sudha. Yeah. So that's why those of you who are not familiar with Python, I have assigned the data science course also for you all. And you can go and watch my Python videos there, okay? And still, if you want me to continue from the Python thing, we'll see it, okay? Again, I will get the majorities thing and then we'll decide, okay? And here I just copy this one and then paste it. So let us see, how the words got stemmed. So after applying the porter stemmer on this thing, in this list, so the running became run and runner became runner and ran became ran and easily became, look here, the end of it became I, better is just better only here. Got it? So that is how we are getting it now. So after stemming, this is what we can see it here. And we have something called the snowball stemmer. The Snowball Stemmer is available as part of your Spacey. Let me just give it a try one more time. Or else we will use the Colab, okay, Google Colab. There you will not have these kind of issues. Sometimes even with Google Colab, you will get some error for the Spacey also. Okay, you don't have to install the Spacey, I think there, but still installation also will not cause any issues. Open a new notebook. Yes, it has opened, and I just try the same thing on Google Colab. So Google Colab is a free Jupyter notebook. Okay, here you can go and execute your script. In case you get any error while installing the packages or something like that in your local laptop, don't break your head. Go ahead and do it here. Okay, it's a free one, but once you upload the data, till the session is active, all your data will remain there. But once you log out of this, all your data will get removed. Okay, you need to be a bit cautious on this one. So next one is I'm going to use Stemmer in the sport import Spacey. Let me see how lucky am I with respect, or do I need to install Spacey? Otherwise, we will install the package Spacey and then we'll proceed. And I'm going to click on code. In the interest of time, what I'll do is I'll just from snowball stemmer import stemmer. See, there is no issues here. From snowball stemmer import stemmer, and then from snowball stemmer import import English using English stemmer. Okay, it is case sensitive. Rather than saying case sensitive, it is a camel case. What do you mean by camel case? The first and the middle of the thing, right? It will be capsulator. Okay, it's good. It's working fine, the snowball stemmer here. And now what we will do is, we already tried with this one. Let me just go ahead and try the same thing on cloud also. No issues. And here the porter stemmer, I'm going to use it in the next line. Better we'll use it in the next line, okay? And then I'm going to say this one. I just created an instance of the class porter stemmer, and then I'm going to execute this one. So words, right? We are iterating words here, and then let me just do one thing. I just here itself, why so many cells? Stem rules. Look here, the same thing. Run, runner, ran easily, better. We can see this one, and yeah, we are done. The next one is the snowball stemmer. We'll see how we can use the snowball stemmer. Both of them are equally popular. Sudha, I'm going to say snowball stemmer. Okay, and snowball. Let's give some variable name. Snowball. And here I'm going to say English stemmer. Yeah, you have a class called English stemmer. You will create an instance of the class English stemmer, and then the next line, the English stemmer words. We will use something like words. I just give some meaningful name. Here, the snowball English stemmer dot stem. We have something called stem. 1 second. Stem word. Okay. for word in words. That is what our list, right? The words is the list. And the for loop, it goes and picks up each and every word, and then for each and every word, it is doing this stem. Okay, this one, how do I remember that? Even I don't remember it. Let's give it a try. Since we have been working on a day-to-day basis, we are able to remember it. But in your case, you will also be remembering it over a period of time. Okay, this is called okay. Now what we will do is yeah, the same thing. I just take it, and then this one is having the stemmed words. 1 second. There is a slight variation, but in this case, both of them gives the same output, right? Better running, runner, everything. Okay. And using spacey also, we can do the stemming. What do you mean by stemming? Reducing the words to the root word. The running got reduced to run. Runner remains runner. Ran easily. Not much difference. Better, right? It's okay. Okay, fine. And so this is how we can do the stemming. So we have learnt about how to use the portal stemmer, which is available as part of the model nltk.stem. It is a class that is available as part of this model. And I have created an instance for portal stemmer here, right? So the class, right? For the class, I've created an instance. And then I use this instance name dot stem word for word in words. We are iterating each and every word and then passing that as an argument to the stem method, which is available as part of the class or the instance NLT customer. So this is where we are instantiating the class, right? And then we can see that the stemmed words. So using porter stemmer and snowball stemmer, we can see the same output. Now the question from Sai Sudha is which one is faster? So that we will see it later. Okay, we'll be working on some huge text data. That time we will get to know that. Okay, and ready. So in that case, you learned about how to use different stemming libraries to stem the same set of sample words. Okay, we observed that all the stemming approaches produce same results, but there are some variations. Okay, when you use some other words, you will get some different thing. For example, unknowingly. But here also, I don't think so much difference. Let me do one thing. I will just execute here. So look here, in case you find any issues executing it from your local system Jupyter Notebook, you can rely on Colab. You don't have to install anything here. Simply, you can give it a try. So look here, there is a difference. Unknowingly, right? The L, Y, the Y became I. So here unknown. But even in this case, the snowball stemmer, it reduces it to the base word or the root word, but it is not accurate. There is no vocabulary called unknown, right? Unknown is there, but unknown is not there. So unknowingly, we can say, but unknown should be there, but it is not accurate compared to porter stemmer. So with this, we can make out. Right, so that's what I said. There will be some kind of variations in the case of handling different inflections and variations. Okay, and but what they say, right? The spacey is the one uses lemmatization and produces valid English words, right? Even in the case of stemmer, but that is not the case in this case. Okay, so now you learned about how to do the stemming with this simple example. Anyhow, don't worry, we will take some complex scenarios and we'll work it out. Okay, first you need to understand the basics. That's the whole idea of taking up with the simple examples. Next one is lemmatization. What is lemmatization? Why do we need to do lemmatization? And what is the difference between lemmatization and stemming? The lemmatization is also a normalization technique like your stemming, using which also we can reduce a word to its base or root form. But unlike stemming, lemmatization takes into account the word's context. Okay, so the right? And why do we need to do lemmatization? The same idea. Okay, we want to reduce the dimensionality. We want to reduce the dimensionality, but right by reducing the original word into the base root word, right? The size will get reduced, and so obviously the text size will also get reduced. Okay, we have something called word nut lemmatizer. What I will do is I will just go here and then I will do it here itself. Okay, I just click on the code, and here nltk.stem, I've used it, and here itself the porter stemmer, and I'm going to use the word net word press tab word net. It is not giving the word net lemmatizer. Yeah, you need to press tab so that because it's all case sensitive. Okay, if you type it manually, even though you know the package name, you might tend to make mistake. Hence, press tab. Just type a few words and then press tab. It will give you the code completion facility. Word lemmatizer. Okay, the porter stemmer and word lemmatizer. Remember, these are the things or classes are available as part of the module nltk.stem. So now we are good to go with doing the lemmatization. And here you need to do one thing here, additional step, nltk.download. And here you need to do something like wordnet. Okay, this is the one. This is an extra step you need to do it. Okay, and here already we have used the words that one, and I just execute this one, and I'm going to click on the code. Sorry, right, the next cell. I'm going to create an instance of lemmatizer, the wordnet lemmatizer, wordnet lemmatizer. For the class wordnet lemmatizer, I have created an instance. Now I'm going to use the list comprehension to extract this one. So here what we will do is apply the lemmatization to the sample words. It is always a good practice specify the comments wherever it is required. Initialize the wordnet lemmatizer. Got it. We are done with this step, and next one is I'm going to use the list comprehension. Lemmatized words is equivalent to list called lemmatizer dot lemmatize word. Remember this stem function. Lemmatization lemmatize function. Okay, that is available as part of this lemmatizer class. Okay, for word in words. There is, yeah, everything is correct. I'm going to press enter and I'm going to put it here so that we can see what is the lemmatized one. After lemmatization, how it looks like. Look here, the running, right? So here you can see the running became running. A runner is runner, and ran is ran easily. Look here, in this case, easily, right? There is no word in there is no vocabulary called easily, right? With I, the easily ends with I is not in the dictionary. But whereas it gives us the accurate lemmatization is more accurate than your stemmer. Okay, so that is what we can see here. So the word net lemmatizer in this example from NLTK, we have used to lemmatize the sample text or the words, right? So in this case, it is clearly evident that the lemmatized forms are valid words compared to the stemmed words. The same thing we can do it with the spacey. Yeah. Yeah, 1 second. Spacey won't do it, right? Okay, I'll just show you here. 1 second. I will just select this here. I will just click on the code here. And here, the same thing. Here, I'm going to use the same list comprehension, okay? I just copy this one. In this case, we have something called token.lemma. Okay. Yes. First, you need to make sure that you have done a tokenization. In this case, all the words are available like a token. Okay. And here, yeah, you need to use the import space. Already we did it. And for example, spacey underscore NLP. And spacey, you need to load it. Spacey dot load. And core English core web something called SM web underscore SM. You need to load this one. Okay. English core. So for English language, right, you need to use something like this. Don't ask me what is core web and all. That is the package name, kind of a package. Okay. You need to load it. I'm going to hit the play button here. Let's check. Okay. There are no issues with the spelling. And okay, next one is the lemmatized words. The lemmatized words. I'm going to use the same thing here in the interest of time. Look here, and here I'm going to use the same thing. Lemmatized words, and here token dot lemma. You need to use something different here. Token dot lemma. Token dot lemma underscore for word in for token. Okay, here what we'll use instead of word, let us use something different. Okay, for token. For token in spacey underscore NLP. Okay, spacey underscore NLP. And you need to use this one. I believe all of you are familiar with join, right? Dot join string. If you want to join the strings, how do you do that? If you want to concatenation, you can use join, isn't it? In the case of list. Here, token dot lemma, the list comprehension, I'm using it here. Token dot lemma for token in spacey NLP. And yeah, here there is a mistake. Sorry, I put extra thing here. And in this case, I'm going to remove the comma also. Spacey NLP. Sorry, here spacey NL, because here I have used the NL, right? Yeah, and I'm going to try this. Let me see. I don't know how far. Yeah, it is correct only. Run, runner, and ran became run, and easily, well, better is well. It reduced it, right? Unknowingly. So when you compare the lemmatization done by word lemmatizer as well as the spacey NLP, right? So spacey NLP, this one looks far better, right? Running got reduced to run, and runner, it reduced the the word to the root word. So in that case, this one is far better compared to even look at better, right? It got reduced to well, and the unknowingly became unknowingly, right? It's really good. So in this case, the spacey model, right? We have loaded the English language model, and then we process the words, right? The words the list words. So in this case, the lemmatized forms produced by the spacey consider the context and parts of speech. So that helps us to, this can lead to the different lemmatization compared to simple stemming. Okay. So this is the lemmatization is, often preferred over stemming. To make sure that you want, when you reduce the word, right, it should not get, see, in the attempt of reducing the word to the root word, you're not supposed to convert or transform it with something meaningless word, right? So once you reduce it to the base root, the root of the word, right? Still, it should give the context. It should give the accurate thing. Otherwise, it is not much helpful. But now the question is then, why should I worry about stemming? Better I can do the lemmatization. If the text size is very, very huge, if your text document size is very, very huge, in that kind of situation, if you want to do the text classification, better you can go for stemmer. Okay, better you can go for the stemmer. Okay, but in the case of in for search engine or the language translation, those kind of situation, obviously the word accuracy should be good. In that kind of situation, machine translation, language translation, that kind of situation, you can use the lemmatizer. You can do the lemmatization. You can use WordNet lemmatizer, or you can use the Spacey lemmatizer. Okay, the Spacey is pretty simple. You need to load the English language related package here. That's all. Okay, you're all set. So what is the difference between stemming and lemmatizing? What is your understanding? The interview, they'll ask you, stemming is nothing but the process of removing the prefixes and suffixes and other affixes from your words to obtain its root form, right? This is called your stem. Stemming is a more aggressive process, but not always it produces a valid word. Okay, but it is, it is kind of a computationally efficient one. It doesn't require too much of CPU. Okay, and lemmatization. In the case of lemmatization, it involves the converting the word to their base or dictionary form. We can say dictionary form. This is called your lemma. Okay, unlike stemming, the lemmatization takes into account the words, parts of speech, and context to make sure that the resulting lemma is a valid word. The classic example, unknowingly, right? In our case, unknowingly. But when I used unknowingly in my original text, when I tried the stemming, it gives me something, something strange, right? The strange root word. There is no vocabulary. We don't see this vocabulary, right, in our dictionary. Unknown. Something wrong here. So in that case, lemmatization is your best fit. Okay, you need to take a call which one you need to use it. For example, like I said, in the case of text classification, you can go for the stemming, and if you mention language translation, something like in that kind of situation, you can go for lemmatization. Okay, so what is the next step? What is the next thing? The next one is the feature extraction.